Hi, and welcome to your next video lesson. In the last video, we started with the properties of functions. In this lesson, we are going to finish off the rest of the functions. So we're going to keep going over the key properties of graphs, all those definitions you learned last lesson, and then we're going to be able to graph and recognize all of the key functions. So the three that were done last time plus the rest of them. Now, before moving on, there's a couple things that I realized. I don't know what that Sulio guy was doing back in 2019, which is when that the last video lesson is from. He must have been real tired or distracted or something, but there's one mistake with the intervals of increase and decrease that I just want to go over and correct with you. And again, I apologize for that 2019 Sulio guy. So, when we're talking about the intervals of increase and decrease, and we're going to put arrows on the end here. So we're going to go left to right. So as I go left to right, so if we follow, something happens right there. So that's technically called a local minimum. And this right here is a local. So something happens here at the minimum, and something happens here at the local maximum. And what happens is, it turns, it changes direction. And so again, if we go, so I go left to right, I'm heading down here. As soon as I hit that, I go from being a decreasing function to an increasing function. However, at any peak or valley, or local minimum or local maximum, technically, it's not increasing or decreasing, it's flat. And we're going to learn more about that in future units. So again, as I go left to right, so I'm heading down, I am decreasing. So from negative infinity, and that was -1. Now the mistake that was made in the previous lesson was for some reason I made it a square bracket. It should be a circular bracket, which means does not include. So from negative infinity to -1, it's decreasing. At -1, it's a local minimum, which means it's neither increasing or decreasing, it's actually changing. Then for the next part of the graph, from -1, go left to right, I'm increasing, but as soon as I hit 1 on the x-axis, that's 1, it changes. It goes, it's a local minimum, or a local maximum, and it changes. It goes from increasing to decreasing. So that's an interval of increase, and that, again, does not have a square bracket. Does not include those points. So circular brackets. And then to finish off the rest of the function, going left to right, as I go left to right, my function is decreasing. So that's an interval of decrease, and that would be from 1 to infinity. And again, circular brackets instead of square brackets. So I do apologize for that. You're going to have to go back and either make a mental note or just quickly change that. That was the only mistake. Well, the multiple mistakes, but the same idea for some reason. That guy decided to put square brackets. Now that same mistake was made here as well. So again, 0, 0, 1, 1, -1, 2, 4, 2, 4. And as I go left to right, so again, we're just going to change our brackets. So as I go this way, once I hit here, that is a minimum. It doesn't do anything there. It doesn't increase or decrease. It changes from a decrease to an increase. So my interval of decrease as I go left to right, negative infinity to 0, but with a circular bracket, does not include. Nothing's happening at that point. And then from that point onward, heading left to right, I'm increasing. From 0 to infinity, circular brackets. Absolute value, same thing. I must have been really in love with square brackets at that time. This basically, we know, does this, makes a V. And again, at that point, it isn't increasing or decreasing. It actually is changing from increasing or decreasing to increasing. So as I go left to right, heading this way, that's an interval of decrease, negative infinity to 0. And then keep going, heading this way. I'm increasing, my graph is getting higher, 0 to infinity. So just notation on the brackets, that's all. Okay, so now we are ready for the rest of our functions. And normally you'd have to memorize all of these key properties, but since your test is going to be essentially open book at home, you just have to be able to know what these mean and be able to refer to them. And for an exponential function, it's really b to the x. And your base can be anything, and in this case, my base is 2. So, if we don't remember what this looks like, x and y, we can do a quick little graph of our parent points. And let's just pick the standard numbers. So 2 to the negative 2, remember this is 2 to the x. 2 to the negative 2 is 1 over 4. We're going to keep things as fractions for advanced functions. So 1 over 4, 2 to the negative 1, 1 half, 2 to the 0, 1, 2 to the 1, 2, 2 to the 2, 4. So there is our parent points, and we can graph those. So negative 2, really close to the x-axis, negative 1, 1 half, 0, 1, 1, 2, 2, 4. That's going to keep going like this, and this is going to keep getting closer, but it's, even though it looks like it touches, it's not going to touch. And instead, what we have there is we have an asymptote. And you would have done this function in grade 11, hopefully you remember, but we have an asymptote. So as long as there's no transformations done, this will never cross or touch the x-axis. And we do asymptotes with dashed lines. And we had to label our asymptote. And that has the equation y equals 0. All right, now ready for all of our key features. So domain. Domain can be anything. Well, that's a nice curly bracket. Second one left a little bit to be desired. Range. Range can be anything above 0. So y is any real number such that y is greater than, can't be equal to 0 because it doesn't touch it. Intervals of increase. So as I go left to right, am I increasing or decreasing? I'm forever increasing from left to right. So from negative infinity to infinity, and circular brackets can include infinity. Intervals of decrease, there's none. Continuous, is there any gaps in your graph? There are no gaps in our function, so continuous. Asymptotes, there's a horizontal asymptote, which I'm going to write HA for horizontal asymptote, and it is actually the equation y equals 0. Zeros doesn't cross the x-axis, doesn't touch the x-axis, so zeros, none. Y-intercept, 1, so 0, 1. Symmetry, this has neither odd nor even symmetry, so none. And behaviors. So remember, as x goes to infinity, what does y do? So as x goes to infinity, as my graph goes to the right, y is getting higher and higher, goes to infinity. As x goes to negative infinity, so as I go left, my graph is getting closer and closer to 0. So as x goes to negative infinity, y goes to 0. Max or min? There is none. So there's our exponential. And again, our base was 2, but really you could pick a base of anything. The reciprocal. So again, we can make a little table here. X and y. And this is for 1 over x. And you could pick any of those values. So 1 over negative 2, negative 1/2, negative 1. Now here, 1 divided by 0. Can't divide by 0, error. So what that means is you have an asymptote. X can't be 0, which means you have a vertical asymptote. 1 divided by 1 is 1, 1 divided by 2, 1/2. So this is x, this is y. So negative 2, negative 1/2 is right there. Negative 1, negative 1. Vertical asymptote is 0, 1, 1. And 2, 1/2. And you could put more points in if you want to. So hopefully you remember from grade 11 what this one looks like. If you don't, so we already know there's a vertical asymptote at 0. So we'll put a dashed line in. And there's also a horizontal asymptote. It'll never touch 0. So we have both a vertical asymptote and a horizontal asymptote. And remember, an asymptote means you got to get really, really close to it without touching it. So let's label these. X equals 0, y equals 0. And what's the only way you can get closer to both asymptotes without touching it? And again, you can sub more points in if you want, but it does this and this. So there's our graph of our reciprocal function, now ready for domain and range. Domain. X can be anything except for one number, 0. So x cannot be 0. Looks like I've given up on those curly brackets. Range. Range can be anything except for 0. Intervals of increase. So as I go left to right, so you put your finger on it or you put your pencil, you are actually never increasing. I'm decreasing on the left side, and then if I switch over to the right side, I'm also still just decreasing. So intervals of increase, none. Intervals of decrease from negative infinity to 0, but does not include 0. And then it's also decreasing from 0 to infinity, and again does not include because my graph doesn't exist at 0. Continuous or discontinuous, obviously there is a gap in my function, discontinuous. Asymptotes, there are 2. Vertical asymptote, x equals 0, horizontal asymptote, y equals 0. Zeros, there are none. Y-intercept, there are none. Symmetry. So going back to your note on symmetry, you can think of it as rotated 180 degrees or reflected in the x and reflected in the y. How you think about it visually is up to you. I like to think about it as reflection, so if I take the right side and I reflect it down and then across the y-axis, I will get the exact same side on the left, therefore it is odd. They're definitely not a mirror image of each other, so it's definitely not even. End behaviors, as x goes to infinity, as I go to the right, y approaches 0. As x goes to negative infinity, so as my graph goes to the left, my function also goes to 0. Max or min? None. Our next function is the root, so square root, x, y, and if we want to come up with some key points, here we can't pick -2 or -1. In fact, you can't pick anything negative. You can't take the square root of a negative. And while you can take the square root of anything 0 or above, we want to stick to nice numbers. So the first nice square root is 0, which square root of 0 is 0, then 1. Square root of 1 is 1. The next nice square root is 4, which has a square root of 2, 9, and 3. If you want to do more, you're welcome to do more. So 0, 0, 1, 1, 4, 2, 9, 3. And this does not get an arrow going to the left because it doesn't exist down there. So our domain can be anything greater than or equal to 0. My range, same thing, greater than or equal to 0. Increasing or decreasing. As I go left to right, I am forever increasing. So there is no interval of decrease. So this is increasing from 0 to infinity. And again, at 0, nothing's happening. It's not increasing or decreasing. It's just where it starts. Circular bracket does not include. Continuous or discontinuous, that is continuous. There are no gaps or breaks in our graph. Asymptotes, none. Zeros, where does it touch the x-axis? At x equals 0. Y-intercept, 0, 0. Symmetry, this has none. It doesn't actually cross any of the axes. It just touches them both at the origin. End behaviors. So this was, there's one that for sure happens and another one that like you could use, but anyways, we'll talk about it. So for sure, as x goes to infinity, so as I go left to right, my graph is definitely getting higher and higher. So y approaches infinity. That's the one that I care about that you know. Now you technically, well, not technically, some people, depending who you talk to, depending what mathematician or Google site you look up, say you can actually go to negative infinity. Now, even though I don't actually get onto the negative side, saying something like as x approaches negative infinity, or since we don't go over there to the negative side, we could actually say as x approaches 0, it's kind of a gray area, so as I approach 0 from the left, but as x approaches negative infinity, which really we're just going to 0, y approaches 0. So you might see that one pop up. Honestly, I wouldn't worry about that one. we'll give it one of these, just a straight, don't worry about it. This is the one over here, this is the one that we care about. And then min or max, it reaches a minimum of y equals 0, but it's not really a local min or max, so we're not even going to worry about that. So there's our square root function. Now into trig, sine. And we're only going to do sine because cosine is really just a shifted sine graph, or vice versa. So for sine x and y, and come up with some points. We're going to stick to degrees for now, but I'm going to go from negative 90, 0, 90, 3, all the way to 360. And really, since this is periodic, you can pick any x coordinate, but it makes sense to go up by 90s. So you can use your calculator here, or you just remember at negative 90, sine x is negative 1. 0, sine x is 0, 91, 0, negative 1, and 0. So, just to space my numbers out, I'm going to every other one. So, 90, 180, 270. So a negative 90, and we'll call this negative 1 and positive 1. And 0, 0, 91, 180, 0, 270, and it comes back down. So there's our sine x. One cycle of it anyway. Domain. X can be anything. Range, this only exists between two values. I only get as high as 1 and as low as negative 1. So y can be anything such that, start with the lowest number, less than or equal to the highest number. Intervals of increase or decrease. So if I go left to right, so I'm going to trace over here. So as I go from here to here, I am increasing. So I'm increasing. Again, at those local max and min, nothing happens. It's just changing. So we don't include. Oops, don't want the highlighter, I want the pen. So from negative 90 to positive 90. And you notice I left a big space. So we started at negative 90. This is periodic, meaning it repeats. You could pick anywhere. There's an infinite number of intervals of increase. So my graph, so I started here, the exact same thing repeats starting again here. And what's that distance? Between negative 90 and 270, that distance is 360, which makes sense if you remember from grade 11. The period of sine and cos is 360. So all of these points repeat every 360, which means my intervals of increase and decrease repeat every 360. So how do you take care of that? Well, you do negative 90, and then you do this thing plus 360k, and same thing here, plus 360k. And then you have to do this thing, where k, e, and then a weird looking z. The z just is the set of integers. So what this means is if I take negative 90 and add a multiple of 360 to it, and take 90 and add a multiple of that same multiple of 360 to it, I will get an interval of increase. Now that's kind of hard to wrap your head around, so you might want to go back and listen to that part again. Now I'm going to pick up from where I left off, and now I'm decreasing, and that's from 90 to 270. So, and I'm decreasing, so between 90 and 270, and again, it repeats every 360, so plus 360k, plus 360k, and then the same thing, k, e, z, for the set of integers. Continuous or discontinuous, there are no graphs in my graph, it is continuous. Asymptotes, none. Zeros. Now zeros is another thing that keeps repeating. So if I take a look, I have a 0 here and here. I'd get another one at 360. So x equals, I'm going to pick 0 as my first one. And they repeat every 180 degrees. So 0 plus 180k, k, e, z for the set of integers. Y-intercept, 0, 0. Symmetry, it's definitely not a mirror image, so it's not even. If I reflect it down, reflect it across, so reflect it across the x, reflect it across the y, I get the other side of it, therefore it is odd. Now for cosine, just so you know, cosine is even. End behaviors, this is a weird one. So as x goes to, I'm just going to short form it because it does the same thing. So as it goes to plus or minus infinity, as I go to the left, as I go to the right, there is a definite repeating pattern. It goes up to 1, down to negative 1, up to 1, down to negative 1. So how you take care of that is you write y goes to, it doesn't go to any particular 1 value. It bounces back and forth between 1 and negative 1. So what you say is y goes to oscillating. And oscillating just means goes back and forth. So as x goes to the plus or minus infinity, y oscillates, and it oscillates between 1 and negative 1. And cosine would do the same thing. Max or min, I'm not going to worry about it. There's a max at 90, repeats every 360, a min at negative 90, and again repeats every 360. But I'm not really going to focus on this when it comes to testing. Cubic. So, and I think this is our last one. X, y, x cubed. Pick anything for x, x to the negative, or sorry, negative 2 cubed is negative 8, negative 1 cubed, negative 1, 0 cubed, 0, 1 cubed 1, 2 cubed 8. X and y. Plot our points. Negative 2, negative 8. Negative 1, 0, 0, 1, 1, 2, 8. So a cubic looks like that. My domain, x can be anything. My range, likewise, can be anything. Intervals of increase and decrease. Now this point right here, it doesn't turn. The slope or the rate of change actually changes at that point. And that's called an inflection point. So as I go left to right, so if you use your pencil or pen or finger, you actually are always increasing, and you never change. You never change from increasing to decreasing. So intervals of decrease, there is none. Interval of increase, you're always increasing from negative infinity to positive infinity. Are there any breaks in your graphs? No. So therefore it is continuous. Asymptotes, none, zeros, crosses at 0. Y-intercept, same thing, 0, 0. Symmetry, this is odd. So not a mirror image, therefore not even. If I reflect the right side down and across, I get the left side, therefore it's odd. End behaviors, as x goes to infinity, as I go to the right, my function goes on forever. As I go to the left, negative infinity, my function keeps getting lower and lower, therefore it goes to negative infinity as well. Max or min, don't care about, but none. Goes on forever and ever. So that's it for your key functions. Note yesterday's plus today's. Your seat work is going to be to continue to memorize the properties of functions today. And by memorize, normally in the classroom you'd have to, at home, make sure you know what you're doing with them, but you can always refer to this. And then your first textbook work, there's the pages, 23, number 3, 4, 7 to 9. And I have, by the time you've watched this, I will have posted the page with the questions and the answers to those questions. Now just know there are a lot of mistakes in the back of the book, which I haven't corrected, but if you see that you're wrong, don't just automatically assume that you actually are wrong. If it looks right to you, ask me, ask a friend, post it in the discussion forum, and I'll be able to correct you or tell you that the answer in the back is incorrect. And then I'm hoping by now you're supposed to get an email from Mr. Casillas about picking up textbooks. If you haven't or you're not able to, like I said in my original email, they're not supposed to be planning for them to be picked up until April 26th. So obviously this is prior to that, but I will keep posting pictures of the pages and the solutions if by chance you can't make it to the school or you don't feel comfortable coming to pick up a textbook. Okay, that's it for the lesson. This one was a bit of a long one. I think the other two today are a little bit shorter. Have a good one.